So what exactly is multidimensional mathematics? In order to answer that question, we need to go into the history of maths. When people first started discovering maths, they saw it only with respect to a single axis, the horizontal number line.
X-axis, right?
Exactly. They were able to fit almost every element of maths known then inside it, including numbers, integers, fractions, decimals, rationals, irrationals, and even few radicals. After that, things got complex when people wanted to represent maths graphically, with two dimensions. However, with the discovery of another axis, the vertical number line, or the so-called y-axis, they were able to solve this complexity. Even though people saw mathematics with respect to two different directional axes, they still were not able to solve certain elements.
That's unfortunate.
Yeah. Let me give you an example of what happened. So we have a polynomial here, y equals x squared plus 1, graphed as well as algebraically solved. When we look at the graph, we see that the polynomial does not cross the x-axis at any point, which in two-dimensional terms mean that there are no solutions to the polynomial. When we look at the solved steps, we still find no solutions, as the square root of -1 does not have a value. But according to a really smart guy named Carl Friedrich Gauss, a polynomial with degree n should have n number of solutions, which means in this case we should have two solutions. But unfortunately I can't even find a single one. What does this mean? Does this mean that this problem is unsolvable? Does this prove the great Gauss to be wrong? Are we done with mathematics? Absolutely not. When we add an imaginary axis to this plane, we see that the graph of the polynomial touches the imaginary axis or z-plane at 2 points, which means the polynomial does have two solutions. It's just that they're imaginary. A fun fact about I is that it's made out of the most simplest, the first number ever found, 1. Another fun fact is that when we look at the most beautiful theorem of mathematics, Eulers Identity, do you see that 3 non-terminating, non-recurring, complex decimals e pi I also form something very simple, -1? So do you see that something very complex is turned simple and something very simple is turned complex? How do you think this occurs? Multidimensional mathematics. With just a few dimensions, we're able to solve tons and tons of problems. Imagine if we had infinitely many dimensions, infinitely many axes, infinitely many angles to look at each and every problem. Of course, including COVID-19.